Greetings to respected madam, sirs. My name is Pavan Sai. I'm from CSE AIML from the section C, and today's my presentation is on the topic Twitter powered instruction pipeline visualization for the course computer system architectures. So this is my presentation format. The content is in the order, like I'll be starting with the abstract and next problem statement and introduction to my presentation and the requirements, prerequisites, technologies I used in this presentation, and the literature reviews, methodologies, and conclusion. So I'll be starting with my abstract. So in this presentation I'll be covering the abstract problem statement. Introduction requires techniques used, literature reviews, methodologies, and final the conclusion. So the abstract. The main idea of the project is to combine real-time social media data with my computer architecture concepts. Pipeline visualization normally uses static inputs, but with Twitter data, the input becomes dynamic, making the pipeline behavior consistently changing and more realistic. So the visualization map incoming tweet text to instruction process them through different pipeline stages like fetch, decode, execution memory, and write back, and the display how the pipeline handles hazards, the stalls. Overall, the system makes learning CPUs instruction pipeline engaging and interactive. So the modern processor executes instruction using pipeline, allowing multiple instructions to be processed stimulously. Understanding pipelines flow, hazard stalls, and forwarding can be challenging for students. This project introduces a tweet-powered instruction pipeline visualization where a user tweets assembly instructions and the system responds with a pipeline diagram showing how the instruction progress through fetch, decode, execute, memory, and write back stages. This The aim is simply learning computer architectures using real-time cloud-based visualization. Coming to the problem statement, transitional instructions pipeline teaching methods rely heavily on the theory or static diagrams. Student often struggles to visualize hazard stalls and parallel parallelism. There is no easy to use tools that connects real world data with pipeline processing. This project solves them by taking fast charging to each data and transforming it into pipeline inputs, giving students a real time visual experience. So to develop a HMM based predictive maintenance systems that can clarify conveyor belt health into hidden states, health degradation, faulty user observations, sensor data. The challenge is to model degradation pattern that are not directly visible, that can be inferred from fluctuation in sensors. The goal is to build systems that accurately predict state transitional and provide early warning before mechanical failure occurs. So the instruction pipeline is a key performance optimistic techniques which are used in modern CPUs. So instruction pipelines is a technique where multiple instructions are overlapped execution to increase performance. The pipeline has stages such as IF, ID, EX, MEM, and WB. Um, it improves the instruction throughput by dividing execution into stages. However, visualizing how multiple instructions flow stimulously is difficult without proper tools. So, however, we understand the hazards like raw, var, wow, and structural hazards occur in difficult without visualization. So, the project used Twitter API integration to allow users to send assembly instructions in the tweet. The project has act as a technique aid. It shows how an instruction flow through a pipeline and external factor aim timing. This use tweet makers each run differently, keeping the tools engaging. So the backend processing the instruction runs hazard detection logic and replies with a pipeline visualization image. The this makes computer architecture learning interactive and accessible. So for the requirements for this project, the basic requirements include a system with Python and API access, Tweet development API access, Twitter developer API access, like um, ability to parallelize assembly instructions, a pipeline simulator, backend servers like Flask, Node.js, and Python, hazard detection like logic, raw, var, wow, branch hazards, pipeline diagram generator, manipulab, or custom SVG, the cloud hosting AWS Heroku Render, internet connections for real-time tweet processing, tools for visualizing stages in real time. These software requirements include Python libraries and Twitter like Tweepy, Matplotlib, and Flask for creating the interface. The prerequisites. To understand the project, users need basic knowledge of CPU architecture, instruction cycle, types of hazards, basic Python programming, understanding API calls. These fundamental help is in appreciating the work of the visualizer. Basic understanding of computer architecture, knowledge of pipeline stages, if, ID, EX, MEM, WB. Understanding hazards like data hazard, control hazards, structural hazard. Python programming basics, familiarity with REST APIs, basic idea on JSON and HTTP. The technologies I used uh, involve Python, TWP, Flask, Matplotlib, JavaScript, HTML, CSS. The Python is for backend and logic, TWP for connecting connecting Twitter API, and the Flask Fast API as backend, and my front end is JavaScript and Matplotlib, HTML and CSS for the front end, AWS Lambda EACS render for development, webhook listeners for auto processing tweeting, and for interpreting instructions or natural language processing, and Matplotlib GraphViz for pipeline diagram generation, and Python for server logic, and Twitter APIs version 2. The literature review. Previous works on instruction pipelines teach tools mostly rely on static data sheets or pre-entered instructions. For some students, focuses on stimulating hazards but still lacking in activity. Research papers empathize the real-time system, increase student interest and undergraduating understanding. By integrating Twitter, we introduce unpredictability, which represents real workload variations. The project built upon existing concepts for add real world dynamic inputs. And the computer architecture textbook by John L. Hennis and David Patterson, and the research paper on the instruction pipeline performance, students on hazard detection and pipeline optimization, documentation of pipeline visualization tools used in education, Twitter API developer documentations, and the multiple paper on inactive learning tools for CPU architecture and the concepts. Coming to the methodology includes several steps: data collection, instruction management, mapping, pipeline stimulation, hazard detection, and visualization. And for the data collection, it fetched the real-time tweets based on keyword using Twitter API. And the instruction mapping, where each tweet is turned into an instruction. For example, large length or sentiment may determine OP code or type. Pipeline simulation is used for mapped instructions which enters the pipeline like fetch, decode, execute, memory, write back. Hazard detection. The simulator checks the hazards for inserting stalls whether they are required. And the visualization, a graphic interface display instruction progress with timing diagram. The entire process completes in milliseconds, which gives the user a live demonstration. And well, user sends a tweet containing assembly instructions. Backend receives the tweet via Twitter API REST webhook, and the instructor are parsed and tokenized. Hazard detection such as RAW, WAR, WW. Read after write, which is RAW. Write after read is WAR, and write after write is WAW, which are branch hazards. Pipeline scheduling is logic applies uh, stalls forwarding. A pipe diagram is generated, cycle versus stage. Final diagram is sent back to the user as a reply tweet. The logs and stats stores for monitoring. And the resulting and discussion successful generation pipeline diagrams in real time, accuracy detection of data hazards, of insertion of required stalls, clear visualization of instruction flow across cycles, high usability for student learning pipelines, and for the discussions. Twitter makes the system highly accessible and interactive, helps students visualize pipeline behavior without complex tools, which can extend to support multiple instructions set RISC-V MIPS. Diagram clarity depends on length of instruction sequence. And the conclusion, to conclude, the Twitter powered instruction pipeline visualization is a simple yet powerful tool which is designed for students, educators, and researchers. It enhances learning by combining computer architecture with real time social media data. The tool demonstrates hazards, stalls, and instructions flow in dynamic, engaging ways. Thank you for listening my presentation. Hope you have a great day. Thank you.